How are you again? This little video is on classful addressing schemes. So we'll go through that. A little bit of where some of these numbers come from, and yeah, get a base for A class, B class, C class subnets, and go from there. So yeah. Okay, so we're going to come back to this, and just over to the right here, I have a nice little table, which is what we aim to learn today. So there's classes here, so A class, B class, C class, D class, and E class. Mostly on the internet they've gone. We now subnet those and divide them up because most of the internet is actually too full. So when this was first mooted as a class or a scheme of addresses, you did have organizations which did require a lot of hosts. So if you can see in here, an A class has 16 million different hosts, different PCs, routers, printers, access points, you name it, servers. 16 million, that's quite a big department in an organization, but you know, that was what they had. There were organizations, and still are, that require pure B class, so 65,000. In Australia, the CSIRO, I think, has a B class address, and they use about 40 to 45,000 of those, so there's 20,000 that are lost to everybody else. C class has 254 hosts, and that's mostly very small networks. So what they did is divided up the addressing scheme, the dot decimal notation of the 4 octets, into different classes. And they said, well, okay, the first octet, so the first octet here is this one, this bluer one. So there are 4 octets, so values 1 to 128 there, and then 1 to 128 there is the second octet, the third, and then the fourth are in there. So for us to be able to read our IP scheme, we convert our binary, which is what the computer listens to decimal. And an A class is described as an address that has the first octet that starts with 1 to 127. And we'll come back to the 127 in a bit. So back to 127. So that's to remind me. So an A class, if the first octet has a value within that, so anything from 1 to 127, by definition, then it will be an A class address. And that pretty much means that the value in the first octet is going to have a 1 there, and zeros all across there. And I set up to 127, which implies that we have a 0 there, up to all 1s there as well. So what we can see is that an A class address in binary always starts with a 0. So let's have a look back at our table. So there it is there. So the binary of the first octet, I've just put a 0. Actually that's an O. It won't take 0 and lead it on. And then I've just said, well, all zeros, but effectively it can be all 1s, sorry. So it can be all zeros right across with a 1 at the end, up to that value there, which is 127. So it's the binary, excuse me, in the first octet that determines which class we're in. So for a B class, then there's a different numbering scheme. So according to my little thing here, I said that from 128 to 191 in the first octet, so if I type an address of 170, well, classic 1172, actually that's over here, we'll come back to that, so let's just type in 150, love you, 150.10.2.1 with 24 bits in the subnet mask. If you haven't seen this yet, you will in the future. So that IP address, because the 150 falls between 128 and 190 up there, that will be a B class address. And I'll put just 24 bits in the subnet mask, and we could just as easily put 16 because it falls in, if it's classful, a B class address there. So 128 to 191 as far as B class is concerned. So 128 is this value, and 191 is this value in binary. So we've got 128 plus 32, 16, 8, 4, 2, 1, which is actually 63. So 128 plus 63, which is those ones, will equal 191. And that says it's a B class address. Now an A class address has a subnet mask of 255.0.0.0, which gives us this number of hosts. And a B class address has 255.255.0.0, which gives us this number of hosts, and we'll talk about that in a moment as well. But let's just define what is a C class address, because it says it goes from 192 to 223. So a C class, I've just said, goes from missed it. Always missing those. So that value there is 192. So 128 plus 64 is 192. And it goes up to this value. And you can see a bit of a pattern there. This 0 started there, and it's moved over 1, and it's been replaced by 1s over there. And it's moved over 1, and it's been replaced by 1s. So in the range that I've gone from pretty much from that value up to that value is the actual range of different numbers available to us. So a C class goes from that 192 to this value, which is 223. There it is there. So those three classes is generally what we can use, well, it is what we can use for our PCs. On normal networks. So I'm fiddling around here, aren't I? On most networks you'll find your address range will fit inside that, and just about everything on the internet also fits inside that address range as well. So what about D and E as classes? Now a D class, I've said, goes from 224 to 239, so I think you've got the gist of it now. So a D class is going to have 3 ones at the front, followed by 0. And the range goes from there up to there. So now the first 4 bits have to be the same, and that first value there is 224. And then 224 plus 15, which is those values there, goes up to 239. And that's a D class. Now these addresses up here are normally used for unicast. So you will have a particular IP address on your machine that's unique for your network. It's unicast, it's sent directly to you. So those 3 are all unicast. This address range in here, and certainly the 224s we will look at in routing protocols and other things, are generally multicast addresses. And multicast means excuse me, that we will send out to a number of different devices. So later on when we're playing with routers, one router might be connected to 2 other routers, and it will send out an address, potentially 224.0.0.10 or .6 or .8 or 9, and depending on the protocol that we're playing with, that protocol will pick up and listen to that address. But it's sent across to multiple devices, but not every device across the whole network. Every device across the whole network is a broadcast. So there's a difference between these 3 types of sending information out. Unicast addresses tend to fall into these 3 ranges of classes, and if we get rid of classes, we still play within that range from 1 to 223. multicast addresses start to come into this range, and it's used for some other things as well. But normally you would not assign an IP address to a device in the D class. Now the last one is E class, and it's going to start at 240. So E class excuse me, why am I going down? 2, 3, 4. So 4 zeros in a row is going to be an E class, and it can have whatever it likes at the end because it's never going to have anything over the top of that, so it can go all zeros to all ones. Now that's normally used for academic and potentially military, to work out different protocols and other stuff. So if you don't want to play across this range, you've got a set of addresses you can play with if you're in research somewhere along the line. So the chances of us ever using an E class will be pretty slim. So D class we get to use, but normally it's actually created for us because a protocol has been created that will use one of these multicast addresses. And these unicast addresses, A, B and C classes, we use internally when we're learning. We can use whatever we like. Mostly across the internet, they're assigned automatically by your ISP to different businesses, and they would subnet and manipulate their networks to suit that. Except for a few addresses actually. So in each of these addresses, A class, B class, C class, there is a range of addresses that are not used on the internet. They're local addresses, and they're non-routable across the internet. So in an A class, that address there, anything that starts with 10 in the first octet, will not be routable across the internet. And you'll see them in your home networks, in academic kind of networks as well. But there's a network number that can hide behind network address translation, or NAT. If you don't know about that yet, don't worry, it comes to it. But you can have 16,777,214 different computers hiding behind a device, either NAT or a proxy server, and they would all work quite happily. So bigger organizations might use that address and then hide behind that, connect out to the internet on a valid address on the other side. So that address, what I'm trying to get to there, is non-routable across the internet. And then there are two others. Actually there's a third, but I'll come back to that one. Fourth, sorry, two others. So in a B class range, this range 172.16.00/12, it's not a full B class address because that 12 there says we've got 12 bits in the subnet mask, but a normal subnet mask for a B class is 255.255, which is 8 ones and 8 ones, which is 16. But all this is saying is the first 12 bits, if they match 172.16, then that will not be routable across the internet. And again, you can build quite reasonable sized networks out of that. So in our case, if we were to make it classful at 172.16, then we would have 65,534 different hosts. In fact, this range, if you want to make it classful, would actually go from 16 bits from there up to 172.31.0.0 /16. So there's a bit of a range that we do get within this from 16 to 31 as non-routable addresses if you're using 16 bits in the subnet mask. Just for that one there. So this is from a RFC, so request for comment, RFC. I forget the number, don't know if I ever remembered it actually, but there's a RFC which defines that standard, so you can look that up. Now in a C class, anything that starts with 192.168 for the first 16 bits will be non-routable across the internet. So again, a private address space, and again can hide behind NAT and proxy like the 10, like the 172.16. So if you think of this address space, if we were to make it actually classful, 192.168.0.0/24, so 24 bits in the subnet mask there, same as we've got up here, proper classful. So the first network we can have in there is this, and that can go up to this network here. So 192.168.255.0/24 will be the last network you can have. So in this case we have 256 different networks available to us because that third octet is kind of free. But the standard says only match the first 16 bits, so 192.168. So yeah, a little bit in that. So those are our classes. So that again, back to the start, classes are defined by the address in the first octet, so whatever we type in there. And because computers use binary, if it has a binary 0 there, then it will be an A class in the first, that 128th bit down that row there. And that says it's going to be between 1 and 127. It will be an A class if you're using classful networks. Excuse me. It'll be a B class if we have a 1, 0 at the start. And that's the range that we put in there. And that range goes from 128 to 191. It's a B class, and if you type a value in the first octet like that into your computer and then click on the subnet mask, it'll automatically finish it off and give you a B class, whether you want it or not. The C class has a 110, so back to there, 110, that's our range in there, and that's a C class address. A D class, 1110, and you would assume that an E class, well, it doesn't really matter at this point, but it could have a 0 there or not, and it may well do. I'm not too sure about that. So, there you have classes. We have a bit of info about them. So this is the binary of the first octet, which I've said. So 0 in the first one, 10 for B, 110 for C, 1110 for D. These are the non-routable addresses, so you need to remember those a bit. The other one, I'll just plonk in there for now. These are the number of hosts that you would get out of each network number. So it's over 16 million, well over 16.5 million actually, 16.75 million different host addresses. Add 2 to that if you want to find out how many absolute addresses in there. In a B class we've got 65,500 addresses, and in a C class we have 254 addresses. By default, A class subnet mask is 255.0.0.0, so it's 8 ones at the start. A B class has 255.255.0.0, and a C class has 255.255.255.0. Not applicable down here for all this stuff because it's just a big range, and then not hosted, if you like. Okay, unicast sends to one PC. Multicast, one PC sends to a range of others, but not every other. And a broadcast, one PC or device sends out to every other device on the network. Okay, now there's a couple of addresses that we need to play with. This 127 is normally written up as 127.0.0.1, and that address is loopback. So even in our A class range up here, this 1 to 127, we cannot use or cannot apply an address to our interface which starts with 127. The reason being that sometimes we need to test our actual interface, see if it's running, see if our drivers have been installed, see if our stack is running up to layer 3. So we ping ourselves in a way, and that is an address that we apply to ourselves. It'll never go outside our computer. So 127.0.0.1 is our loopback. And we can also ping our absolute IP address. So if we had an IP address of Let's use a B class, so let's use a non-routable B class, so 172.16, so let's go down there, so 172.16.0.1, and we'll put 16 bits in the subnet mask. If that was our IP address of our interface, we could ping that, and it'll get us a response as well, but we can just as easily ping 127.0.0.1. Actually, better off doing both of them sometimes. Okay, so loopback addresses, 127.0.0.1. And in some PCs, the range actually goes up to 127.255.255.255.254. It'll be the whole range, all 16 million different options of 127. So that whole 16 million different scope, if you like, is all on your computer. It's a nice waste, isn't it? Anyway. The other address is 169.254.0.0, and normally 16 bits in the subnet mask for that one as well. And you would find that in your PC if it did not receive an address from a DHCP server. So if you're trying to acquire a dynamic address and it did not receive that dynamic address, then it's a bit of a linked local address. It will start with 169.254. And the PC will then generate the next 2 octets dynamically, try and come up with a number that's different to everything else across the network. And all your PCs on that network who don't receive a DHCP will all start with 169.254. And they should all end up with a different host address as well, so in those second 2 octets. So that's a way of saying no DHCP has been acquired, but you've asked for one. So yeah, that one needs looking at as well. So that's a bit of a troubleshooting one. So if you do get that, you know there's something wrong. Okay, so that's pretty much all we need to know for classes. I've got another bit of stuff in my little list here which looks a bit messy actually, and we do need it later on to work out the number of hosts out here. What we've done is gone for 2 to the power of 8 minus 2. Now why have we done that? So 2 to the power of 8 will actually equal 256. Now if we subtract 2, then 254 is what we're left with. So later on when we look at subnetting and network numbers, actually I might do it in this video, we need to subtract 2 values out of this address space, because one is the network number and one is the broadcast for that network. There are broadcasts for the whole network, so whole network broadcast is a different address. It is 255.255.255.255, which is all ones. My typing is abysmal these days. So let's put in an IP address onto our binary just to show this, and then we'll come back to these powers. Actually no, let me finish with powers. 2 to the power 0, so this text editor, or this LibreOffice Calc, which is an Excel spreadsheet, didn't give me enough of these little powers, so hopefully you can see them in there. I'll just try and open it up a bit bigger for you. So 2 to the power of 0 is equal to 1. 2 to the power 1 equals 2. 2 to the power 2 equals 4. 2 to the power 3, or cubed, is 8. 2 quadrupled to the power of 4, so I had to change here. 16 to the power of 5, 32. To the power of 6 is 64. 2 to the power of 7 is 128. And 2 to the power of 8 is 256. And you can see these numbers up here. So understanding these numbers is actually quite handy, because we're using binary, which is this 2. There's only two values we have, 0 and 1. And then the power is the number of bits that we're manipulating with. So if I'm got 2 bits, I've got 4 different values I can get if I'm using 2 bits, and that's the power there. 2 to the power 3 says if I've got 3 bits, I've got 8 different values out of it. So I'll show that in a minute, hopefully. Actually, let's do it quickly now. So 2 to the power of 2, I've got 4 different values. I'll just do it quickly down here. So if these are my 2 bits, so I've got a 0 and a 0 to start with. Then I've got a 0 and a 1 is an option. 1 and a 0 is another, it's different. And 1 and 1 is different again. So there's 4 different combinations I can get using 2 bits. How about I use 3 bits up here? So let me chuck a 3rd bit in there. And I can just extend this very quickly. And I'll say it in another video, but there's a bit of a pattern coming here. You can see 0101, 0011, 4 zeros. What's going to come underneath? 4 ones. So if you're ever writing up a big line of these things and you want to check it out, this is the scale that you want to use. So 01010101 on the right hand side, 001111, 0011, 4 zeros, 4 ones. If you've got 4 bits, it'll be 8 zeros and 8 ones. And then this thing here repeats. So there's a lot of repetition in binary, which actually, once you get used to it, makes it a bit easier to use. And you can see it here. So back to this, 2 cubed gives us 8 different values. That's what we've got there. We've said there's 3 bits, 1, 2, 3 bits that we're playing with. How many different combinations do we end up with? We end up with 8 different combinations, and those are they. If you can find another one, or less than that, then I will pay you $1 million. If we've got 4 bits, it'll be 16 different values. So each time we add a bit, we're actually doubling the number of combinations that we've got. It's a bit like compound interest, isn't it? So that's where we start to get these values from. And that's how it works. So play around with these, get used to them, get a feel for it. Okay, so I'm going to go back and look at my network number and broadcast, because I said that the number of hosts we can have is not 256 before, which is the number of different combinations. If we've got 8 bits, 2 to the power of 8, I've said it's 254. And what I said is there are 2 unique numbers in any IP address in IPv4. One is the network number and one is the broadcast for that network. So let's chuck up a number. So I'm trying to think of a number here. Let's go for that one we had before. So 172.16.01/16 was the address. So there's our classes. I'm just going to wipe that off. Hopefully you can remember them. And I'm going to put in binary 172.16. So 172 is one of those, none of them, one of those, so that's 160 at the moment. So no 16s, 18, 14, no 2s, no 1s, and 16 in the second octet. You're just going to have a 1 there, and nothing over there. Now I said it's 001, so I should actually make this a wee bit smaller so we can actually see out to 1 over here. So this is going to be all zeros right across, and I'm going to make a mess, I'm sure of it. Ooh, I didn't. First time ever. Okay, so at the moment what we have there is the binary for 172. Here's 172.16.0.1. Now the subnet I said is 16 bits in the subnet mask, so let's put in 16 bits in the subnet mask. And that's where it stops. So it starts on the classful boundary. Oh, I've gone just too far, haven't I? Having too much fun. So 8 ones equals 255, another 8 ones equals 255, and then 8 zeros equals 0, 0. So that is a B-class address. 172 fits in the range there. There's my subnet mask. I've said 65534, but there are two numbers we cannot use, network number and broadcast. They're already taken out of that. So which are the two numbers we cannot use? So have a look at your subnetting in other videos, but it's actually these numbers. It's all zeros in the host portion, and the other one is all ones in the host portion. Now, the network portion is where these ones in the subnet mask stop. This defines our network number. So our network number is that 172.16.0.0, and that is one of the numbers we cannot use out of this range. It is the network number, and our computers will need that number to determine where to send packets. This other number here, added with our network number, so the network, first two octets, plus all ones, in our case down here, that's our broadcast for this network. That actually equals 172.16.255.255. So that's our broadcast for the network. 172.16.0.0 is our network number. So that's it. We've covered all we need to. So there's a bit in that we've done. We looked at classes, and I've got rid of those now. We worked out that the first octet will go from 1 to 127, but we cannot use 127 because it's our loopback. That's an A class. Its subnet mask is 255.0.0.0. It has 16,772,214 hosts. I've said there's two values I've taken out, not exactly those two values, but there are two taken out because of all zeros and all ones in the host portion. So there's actually 777,216 different values, but we've taken two off because of those. The non-routable address in that range, in an A class, is 10.0.0.0, and it'll have 8 bits in the subnet mask, which is actually the same length as that one. So we're only going to match the first 8 bits. And the binary has a 0 at the start. If it's a 0 at the start in a binary number, in the first octet, it's an A class address. Okay, B class. Its range goes from 128 to 191. It has a subnet mask of 255.255.0.0. It has a range of hosts, has 65,534 hosts. Again, the network number and the broadcast for the network are taken out. So there are actually 65,536 different values in there. In its binary, it'll start with 10 all the time. So it goes from 10, all zeros, to 10, 111, 111. That will be a B class address. It's the binary that defines it. Now the non-routable address is that we only have to match the first 12 bits, and that is 172.16. And you can actually just see it back here, actually, just quietly. First 12 bits is up to there. So there's our 16. So it doesn't matter about these other values here in a B class. So it's only those first 12, so 8 plus 4 is what it's going to match. And that's the B class. And our C class goes from 192 to 223. It'll have a subnet mask of 255.255.255.0, and it has 256 different values, but we take away 2 to give us 254 different hosts. Non-Routable Range, if you like, 192.168, and it's only the first 16 bits that are being looked at there. That's the RFC, the request for comment. It'll start with 110 in the binary in the first octet. Now, some of our multicast address spaces start with 224, so again, unicast is sending 1 to 1, multicast 1 to a few, broadcast 1, well, everything on the network. And that broadcast is either going to be a number like that, which is all ones in the host portion, which is going to broadcast across your network to every device. That has a prefix of 172.16, I'll just say that. If you're going to broadcast to every device on that network, whether they're on the same network number as you or not, then it will be all ones across the board. So 32 ones. I never even said that right at the start, did I? There's 32 bits right across the whole thing. So multicast address range goes from 224 to 239. It is D class. We tend not to modify it at all. It's built into our protocols that we use. It starts with 110 in binary in the first octet, and then right at the end, for educational research purposes, anything that starts with 240 or above up to 255 is going to be an E-class address, and that's an assumption. So 1111, anything that starts with 4 ones will be within that address space. One other non-routable, or should be non-routable address, should be the 169.254. That's normally acquired when you don't get DHCP. And that's it for classful addressing. So play around with it, enjoy it, get used to it, and then we'll hop into subnet masking, and that just changes everything. So thank you for that.